In this video, I want to go over the syllabus for the computer organization class, talk a bit about the course materials you'll have to use as well as software, give you an idea of the types of homework and programming assignments you're going to have, as well as review the assessment outcomes the department has predetermined for this course and how it'll affect, how they affect your grade in the course. So as a reminder, my name is Amos Confer. I'm Associate Professor here at the Computer and Information Sciences Department at SUNY Polytechnic. If you are looking for me in person during the fall or spring semesters, you'll be able to find me in my office at Kinsella Hall, room C118. Pretty much any time that I'm not either in class or eating. I do have meetings that come up now and again, but for the most part, I am in my office ready to help you with whatever you need. You can always reach me via email, or you can call my office phone and even leave a message there if you were otherwise unable to get a hold of me. Now at the bottom of this slide is the catalog summary for this course. We'll review it quickly. Basic idea here is we want to learn over the course of this semester how computers are actually built out of digital circuits to store data, perform arithmetic, and otherwise do the things that our programs ask it to do. And how does it do that in an automated fashion, like as a mindless machine? How can it perform all these different things? Now beyond that, we want to get a bit deeper in how we program computers. Now you should already have some experience in a system level language like C. For this course, that is a prerequisite. And we want to go beyond this basic understanding of programming to think more about the high-level code that we write and the way that it affects the actual machine that it's running on. And once we do that, hopefully, we can start to make some bigger connections about how the actual structure of the machine therefore affects the software that we write. Not just how it affects the software as it is running, but how we might even utilize that information to improve how we develop software or how we debug software even. Here are a number of outcomes related to the class. These are for program level assessment or course level assessment within the program here. There are 6 outcomes, and each of these outcomes, each student is expected to demonstrate minimal competency in by the conclusion of this semester. So that means even if you have a 90% average in the course, which is a solid A-, if you have not demonstrated, say, this first outcome, the ability to communicate about a modern computer with some kind of standard terminology based on the way that I measure success as listed here, then you are not going to be allowed to pass the course. And that's because this course is a prerequisite to quite a number of other courses in the degree. So the outcomes, the 6 outcomes that we're going to look for you to be able to do by the end is 1, you have to communicate effectively about modern multi-layered computers with standard terminology and measurements. You need to be able to convert between data and number representations and show how to perform arithmetic at low levels, not just traditional doing addition or subtraction. You're going to need to know how to do this, say, in binary, in a number of different representations. We're going to have to create, evaluate, manipulate a variety of Boolean algebra functions. So you're going to learn a lot about Boolean algebra, which should be reinforced by one of the prerequisites for this course, discrete or finite mathematics. We're going to construct a bunch of combinational and sequential circuits. So we're going to learn a lot of the key circuits that are inside of computers, like the ones that do arithmetic and the ones that represent memory. And then the last 2 are informing us that we're going to take the computer organization knowledge that we develop over the term and utilize it or demonstrate it in some form or another using high-level language programming and low-level language programming. Now what I've got here on this slide is a set of typical homework assignments associated with this course. And if you are reviewing this material for a fall or spring semester brick and mortar course, it is very likely that the homework assignments that are listed here will be a close model to the type of homework assignments in both the nature of the material and the quantity of assignments to what you will actually be doing. If you are in a summer course, an online summer course in particular, this is a very compressed time frame, just under half the normal length of a traditional semester. And so you're not likely to have this exact number of assignments, but the same material will be covered just in a compressed number of assignments. Here is a typical list of programming assignments. The same basic thing applies. If this is a brick and mortar class for a full term in the fall or spring semesters, you should expect to do a bunch, 3 or so high-level programming assignments, and then about 4 assembly language programming assignments. In the summer term, this might vary a little, but it may actually be close to this. We might do, say, 1 fewer assembly language program and just combine the material from the one we lose with 1 or 2 other assignments. The textbook that we'll be using for this course is called Computer Organization and Design Fundamentals by David Tarnoff. The image here comes from the cover art of that book, just so that you know you found the right book. And it's available online for free at the website I listed here, which is Tarnoff's professional webpage. You can also acquire a full PDF of the book from lulu.com if you wish, and there's information about that on the website listed. I want to take a brief moment to talk about grading, because I feel as if the way I grade is a little bit unusual today. I think most students are used to things like homework assignments being worth, some percentage of the pie, and tests being worth some larger percentage. So homework assignments could be 20% of the grade, and tests could be 30% of the grade, and participation in class and web forums could be another 15%, things like that. I get lost in this myself, and I never feel like I can come up with a breakdown that seems totally justified. So instead, I'm going to take the lazy route here, as I do in almost all my classes now, and I'm just going to do flat averaging. So no matter how many exams we have or how many homework assignments we do or programming assignments that we do, every single one of them in the end is going to be worth the same amount toward your final grade. So we're just going to take all of the grades for everything that you've done and do a flat average. Now the nice thing about that is not only is it easy for me to calculate, but as the course moves through the term, all assignments that you have grades on, you can trivially find the average of. So you don't have to worry about interpreting your grade so far, whether you've applied some formula of varying percentages correctly, although you ought to be able to do it. What students very often ask, or historically asked me to tell them what their grade is at some given moment. And I just don't want to do that all the time, and you should be able to do it. So the flat average will make that easy for everyone. Now, in a given assignment, I follow the same philosophy. So if you have a homework or an exam that has exactly 10 questions, each of those 10 questions will be worth 10% of that particular homework or exam. Even if one of those questions asks for you to tell me what the acronym for central processing unit is. Oh my God, that's a horrible question. But maybe it'd be the other way. What does CPU stand for? So one question could be, what does CPU stand for? And another question might ask you to develop a novel circuit that provides a particular logical function. Very different levels of difficulty, but we will call them equal in terms of points. Now that means in any exam or program or homework situation, you should always do whatever material you're the most comfortable with first. A good general rule, but in this case, because of the flat averaging, that will also get you the highest grade, right? The biggest return on investment. And so that should be pretty good. Now, the flat averaging makes everything easy for grading. However, it does mean that when you skip a problem or you skip an assignment here or there, you may discover that that has a greater negative impact on your grade that you might otherwise experience in a course where, say, all of the homeworks together only count for 20% of your grade. So please keep that in mind. The flat average here works both ways. If this is a fall or spring brick and mortar class, attendance in class is mandatory. I'm not going to read all this to you, but that's the basics. If this is an online class, I definitely expect that you tend to viewing these lectures and do the reading assignments and your homework programming assignments early and communicate with me as frequently as you can and perform any other tasks I might ask of you to ensure that I might do for me to understand that you are actually involved in the course over the term. So that's the closest thing I can do to attendance here in the online session. In the student handbook, there is a code of academic conduct. This applies in great deal mostly to things like plagiarism, but there are a variety of other activities that fall under its purview. So you may want to read it, but the basics are here. I just expect that no one will plagiarize or do anything else against this particular code of conduct. But in particular, plagiarism is certainly a big issue to me and a big issue to other faculty, and faculty here, and a big issue in the real world. So to resolve early some issues related to this, I want to encourage all of you to work together. I think you will find that if you meet in the library or whatever the online equivalent of meeting in the library might be, and start to strangle each other, arguing about, where does the pivot really go in a quicksort, that's going to be how you learn the most, because you're going to be making arguments about material, trying to explain something to somebody else, which always reinforces the material for yourself, and then hearing the way they receive what you have. You'll also be listening to material presented by other people. I want to encourage that as much as I can. So please, please do it. However, when you turn in any homework or programming assignments that have been completed in this fashion, there's likely to be similarities between yours and the other individuals. So go ahead and, as bold and as big as you can, identify on those assignments whom you worked with and make sure that they identify that they worked with you. And then at the very minimum, the basic version of plagiarism where you are presenting material as if you did it alone just isn't there. Right? It doesn't mean that I will still find that work excellent and everything will be okay. But at least you don't have to worry about that basic issue of plagiarism. Now there's a second version of plagiarism that I want you to concern yourself with. And that is one where you may find almost complete solutions or complete answers to something from another source, right? These kinds of solutions, whether you cite them appropriately or not, are just not satisfactory in my mind. I want to see that you are doing the majority of the work, whether it is novel work that you're doing with another student who is doing novel work. But that's fine. I just don't want to see that I ask a question on a homework assignment, and then if I were to type that question in Google, I could find your answer, right there in the first or second page of results. It's just not appropriate. You can look for information using whatever resources you may need, but you need to manifest a solution to the homeworks, to the programs that is yours. But please cite anything that you're using for this stuff And then we don't have to worry about the issue of plagiarism and academic conduct. If you need any special accommodations for the course, there's some information here, and you'll find this repeated on the syllabus in the class website about what you'll do, and then we'll do whatever we can to help you out. So that's it for the syllabus. If you have any questions, please contact me through the course website or through my email. And I hope you enjoy the course. Let's get started.